Hi, my name is Mark and I'm a QUB student.
Hi, my name is Sean. I'm a QUB student.
Hi, I'm Hayden and I'm an ASU student.
Hello, I'm Alex and I'm an ASU student as well.
And this is our presentation on a smart sprinkler idea. So to save resources in both Phoenix and Belfast, we decided to cut down on water waste of sprinklers. And we discovered that this is a problem in both the UK and Arizona, as the UK's demand increases for sprinklers and Arizona is undergoing a drought. So the solution that we decided was a smart sprinkler. So what it does is it uses sensors like temperature, weather data, moisture, and sunlight to decide if it should water. It also has a boundary sensor that uses a camera and an encoder to detect the edges of the field and set the range that the sprinkler waters to make sure it only waters inside the grass. It also has a self-charging feature which uses a motor built into the sprinkler head as a hydroelectric generator, so it can charge a battery in the sprinkler when water is running through the sprinkler. And we also want to make sure that these sprinklers can connect with each other via Wi-Fi and have all the main processing done on a hub that isn't on the sprinkler. That way it can use all the data it's gathering. So what we have here is just an example of using edge detection to find the edges of grass, which is what we'd use to make sure the sprinkler is only watering grass. And this is just a diagram of the sprinkler we made where all the sensors would be and how it would work roughly. And then what we found is there's a market for this, and the market we're aiming is the commercial market and more of a high-end sprinkler like $100 to $150 range. And we found that this is a viable market to go into because it's expected to grow $1 billion by 2022. And current solutions like irrigreen sprinklers and grow sensor kits don't quite satisfy the need we want because they still require human interaction on the end, and you have to install and add additional sensors, and they're not all at the sprinkler level.
So first the user would end up pairing the sprinkler to the hub, then they would install the sprinkler, launch the app, and run the calibration based off of some of their inputs, and then they can leave and relax, and the sprinklers would automatically water based off of soil conditions and other sensor data. So the system is controlled by a microcontroller that's linked to a Wi-Fi module. That Wi-Fi module communicates with the hub, which is connected to the internet, where you can get the weather data and transfer that back and forth. And this hub is controlled by a computer or a mobile device. So we estimated that the sprinkler would end up costing about $50, 20 of that being electrical components and 30 of that being mechanical components. And here you can see just a general flow diagram of it powering on, seeing sensor data, and based on that sensor data and weather data, you could see if you're going to water, and then you would log that instance and then loop around and keep on running that loop. For use case, we're going to end up having it where you have the sprinklers connecting directly to the hub or to each other to relay data and relay images for data calibration. And here you can just see some of the temperature and moisture data that we'd be using in our demo.
So we were in charge of the coding portion of the challenge. This is mainly to showcase the functions and different methods and things that would need to be used for calculating the specific values for inputting into the sprinkler to water the specific area. First off, you can check off the status of each sensor. This could be used for a mobile app and be able to visualize on a map that people can look at and see which nodes are still up or down. Secondly, there is the angle that the sprinkler will need to move to. Distance value say 10 meters, but initial velocity of 5 meters per second. You'll notice it returns not a number. This is because the pressure is too low, so you could use a feedback loop here until the pressure is increased so they can reach a distance. That could be used in further implementation. Thirdly, there is the distance between the points, so choose sprinkler 4 and sprinkler sensor 1, and you can see the distance there between the points.
This is a demo of the light detection system of the sprinkler. When the blue light turns on, that means it's watering the fields, and then it turns off once it detects high intensity sunlight so it can stop watering so we don't waste water to evaporation.
Here you can see Hayden is adjusting the potentiometer. This is changing the maximum and minimum angle of the sprinkler so that it will not spray on the sidewalk and only on the grass.